Welcome back, Algebra 1 students, to another Regents review video. This is the Algebra 1 Common Core Regents exam for January 2018. These are going to be the solutions to parts 2 through 4 of this examination. These are the open-ended response questions that require your extensive knowledge of the mathematics of algebra. So, without further ado, let's talk about a few things first. Do not cheat. I promise you. These questions, I was going through these just one more time again. The part 2s, they're good. Part 3s, they're good. Actually, there's a mistake that the State Education Department made. So we're going to go through that in about 45 minutes from now. And they're good. But even though that they're good, it doesn't, give you the right to cheat. Just don't do it. You need to do well on this exam, right? Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate the financial support if you could give me literally $1. And visit my website at www.nysmathregentsprep.com for more math content in Algebra 1 and your future mathematical subjects. I do geometry. That is my favorite subject. And I do Algebra 2 as well. And hopefully in the future, some more stuff. And I use the TI Inspire CX calculator. That link can be found on my website. Everything that I just said can be found in the description below. Without further ado, let's jump right now to the part 2s. Now, folks, these are part 2 questions. These are worth 2 credits each. These are going to go by incredibly quickly because they should go by incredibly quickly. They're easy 2-point questions that you should rack up very quickly. How many times did I say quickly so far? 4 times? Because it is quick. It's quick. Let's go on to number 20. All right, let's take a look at 25. On the set of axes below, graph f of x is equal to the absolute value of x minus 3 plus 2. We have to go to our graphing calculator. So, I'm going to type in the absolute value of x minus 3 and plus 2. All right, so we have this absolute value function. Control T. I'm going to find the quote-unquote turning point. And the turning point is at the point, let's see here, 3, 2. It's at the point 3, 2. So what I do is I start at the turning point, and I go 3 above, 3 below, and I copy my list down. So we have x and f of x, or y if you want to. Doesn't really matter to me. And we have 0, 1, 2, 3, 4, 5, 6. I'll move my head in just a moment. And we have 5. These are the corresponding y values. So we have 5, 4, 3, 2, 3, 4, 5. That's all done. Now all you need to do is go ahead and graph this on your axes. So 1, 2, 3, 4, 5, 1, 4, 2, 3, 3, 2, 4, 3, boom, boom. We're almost done with this graph. All we need to do now is take a line, or you need to take your ruler. I could use these tools that I have on my computer. And I am going to basically connect these points. I'm going to make that a little bit thicker, just so you could see. So we have this, and we have this. Nice. And now when you're done, label it. Make sure you have arrows on the end, by the way. And label it. F of x is equal to the absolute value of x minus 3 plus 2. And that, ladies and gentlemen, is how you do that question. Easy 2 points, right? That's all you have to do. Moving on to number 26. Determine all the zeros for m of x is equal to x squared minus 4x plus 3 algebraically. So, by now, we know that the order of factoring is GCF, followed by the difference of 2 perfect squares, followed by the trinomial method. By the way, I say difference of 2 perfect squares, like, why is it not DOTPS? It's really the difference of 2 squares, but I say perfect squares, just so you understand that. So what we're going to do is figure out, is it a GCF dots or trinomial? And if it's not any of those, then we have to try some other things like quadratic formula, completing the square, so on and so forth. Well, this is not a GCF, not a dots question. Maybe it's a trinomial question. What adds to negative 4 multiplies to give you positive 3? Well, that's negative 3 and negative 1. So we could factor this to x minus 3. X minus 1 is equal to 0. They're asking for the 0, so I just said everything equal to 0. Because negative 3 times negative 1 gives you a positive 3, and negative 3 plus negative 1 gives you negative 4. Great. Set up your famous t-bar. We get x minus 3 is equal to 0. X minus 1 equals 0. Solve for x. We add the 3 on both sides. We get x equals positive 3. Add the 1 on both sides, and we get x is equal to 1. So your answer is just simply x is equal to the swirly brackets of 1, 3. That is your answer, ladies and gentlemen. There's nothing more that you need to do. Moving on to 27. The distance traveled is equal to the rate of speed multiplied by the time traveled. If the distance is measured in feet and the time is measured in minutes, then the rate of speed is expressed in which units. Explain how you arrived at your answer. So this is what they're saying. They're saying that the distance traveled is equal to the rate of speed times the time. Now, we know that the distance is in feet. We know that the rate of speed is, we don't know what the rate of speed is. It could be miles, kilometers, we don't know. And the time is in minutes. But the rate of speed is actually what we're trying to find. It says, then the rate of speed is expressed in which units? Well, in more condensed letters, this is really saying d is equal to rate times time. That's distance equals rate times time. That's a very popular formula, not on the Regents exams, but especially on the SAT exams. They use distance equals rate times time a lot. But we know that the rate of speed can be expressed as distance divided by time. All I did, this is actually a literal equation. All I did is I just divided both sides by t. And I solved for r, which I got r is equal to d divided by t. Well, we know if the rate is d divided by t, which we know that the distance is expressed as feet and the time is expressed as minutes, I got it. It's feet over minutes, which is feet per minute. So that's your answer, folks. It's actually feet per minute. So if the distance is measured in feet, by the way, it does say explain your answer, so you need to use English, use words. So if distance is measured in feet and time is measured in minutes, then the speed is measured as feet per minute. And we are done, folks. Feet per minute. Done. Happy. And that's how you do that question. That's an ugly smiley face. All right, moving on to number 28. Determine if the point 04 is a solution to the system of inequalities graph below. Justify your answer. So, the point 04. Go up here. 0, 1, 2, 3, 4. That's only in one solution set, folks. Or one system of inequalities. That's only in the solid line inequality area. The point should be over in this big S solution set that I just drew in order for it to be a solution. By the way, the inequality, I don't know why. They gave you the solid line, but they didn't give you the dotted line. The dotted line is y is less than 1/2 x plus 2. I'm going to use this a little bit later on in the explanation. It says, determine if the point 04 is a solution, justify your answer. Well, the answer is the point 04 is not a solution. If you want to be more specific, it's not a solution to the system of inequalities shown. That is the proper way to say it. So then we could further say that this point is not located in the solution set labeled as S that I drew in the graph above. As long as you indicate to the reader that you drew in that solution set and you say it in your answer, you could absolutely say that. Or you could further say this information. The point 04 satisfies the inequality y is greater than or equal to negative 2x plus 4, but does not satisfy y is less than 1/2 x plus 2, which is the inequality that I found that they did not give to you for some unknown reason on this graph. And if you want to justify this even further, plug in the point 0, 4 into this inequality. Well, given the inequality y is less than 1/2 x plus 2, plug in the point 0, 4, we get 4 is less than 1/2 times 0 plus 2. Really, 4 is less than, well, 1/2 times 0 is 0. 4 is less than 2? Wrong. That is an incorrect statement. That is a false statement. So that is how you explain or justify your answer. Annoying, but it's doable. Moving on to number 29. If the zeros of a quadratic function f are -3 and 5, what is the equation of the axis of symmetry of f? Justify your answer. So there are two very simple ways to get this question right. Either you could do it the incredibly fast way, or you could do it the way that I did it. I didn't mind showing work. But the axis of symmetry formula is x is equal to -b over 2a. That's the formula that you need to know to get this question right. Or you could do this way. The axis of symmetry is halfway on a quadratic. It's halfway between the two given x values. This is x is equal to -3, and this is x is equal to 5, because these are roots on a quadratic. The axis of symmetry, again, is halfway between these two roots. So you could use really the midpoint formula, which is you take x1, add it to x2, and divide it by 2. Well, that's just going to be -3 plus 5 divided by 2. That's going to be 2 divided by 2, which is equal to the number 1, which is equal to x. So, ladies and gentlemen, the axis of symmetry formula is x is equal to 1. That's how you do it very quickly. Now, I didn't mind showing my work. That's the first option. This is option 2. This is option 1, and this is option 2. Option 2 is a little bit more in depth, but it shows that you have a deeper understanding of the material as well. If the roots of the quadratic are -3 and 5, then the factors are x plus 3 and x minus 5 are the factors. So if these are the factors, why don't we go ahead and set up an equation? F of x is equal to x plus 3, x minus 5. Because we know that this is a quadratic, we can multiply them, and we can distribute. First, outer, inner, last. So we get f of x is equal to, this is going to be x squared minus 2x minus 15 when you combine like terms. Now, in this equation, a is 1, b is -2, c is -15, because remember, all quadratics are in the form of ax squared plus bx plus c is equal to 0. That's where I got my a, my b, and my c values from. Just take the numbers or the coefficients in front of each term. But I said to you before that the axis of symmetry formula is -b over 2a. Simply plug in the numbers that I just listed here. X is equal to -b over 2a, which is going to be -2 divided by 2 times 1, which is +2 over 2, which is 1. So the axis of symmetry formula, again, the axis of symmetry, not formula, but the axis of symmetry is 1. X equals 1. Make sure you write x equals 1. It's not y equals 1. It's x equals 1. And that's how you do it. Moving on to number 30. The formula F sub g is equal to g m1 m2 divided by r squared. Calculates the gravitational force between two objects where g is a gravitational constant, m1 is a mass of one object, m2 blah, 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 blah. It says here, state the positive value of r in terms of F sub g, g, m1, and m2. So they're saying to you, solve for r. Solve for the positive value of r. So all you're doing is you're taking F sub g and you're solving for r. Great. Let's do it. The first thing that I would do, personally, is cross-multiply this stuff. Put F sub g over 1 and cross-multiply. So we have F sub g times the r squared, and we have the g m1 m2 times the 1. So we have r squared, F sub g is equal to g m1 m2. Now, continuing to solve for r, we divide by F sub g on both sides. We have r squared is equal to g m1 m2 divided by F sub g. Now to solve for r, because it's asking you to solve for r, we got to take the square root of both sides. Take the square root. So now we have r is equal to the square root of g m1 m2 divided by f sub g. You can't simplify that any further. By the way, do not write plus minus. That is a no-no. It specifically says positive value. So we don't care about plus minus. We only care about the positive value, which is what's listed right there. So that's your answer. R is equal to the square root of g, m1, m2 divided by f sub g. All right, moving on to the next the next question. Number 31. At Mountain Lakes High School, the mathematics and physics scores of 9 students were compared as shown in the table below. State the correlation coefficient to the nearest hundredth for the line of best fit for these data. So, correlation coefficient, easy stuff. Go to your graphing calculator and open up a lists and spreadsheets page and start typing. So this is going to be mathematics and physics. Here we go. So we have, ooh, that's a bad score, 55. Don't get that on your Regents if you're cheating right now. 93, 89, 60, that's another bad score. 90, 45. Oh boy. 64. I personally would have passed that kid. 76 and 89. And for physics, 66, 89, 94, 52, 84, 56, 66, 73, and 92. Okay, so those are the numbers that we have typed in. Click on Control Doc, add a calculator. Now, this is a line. Now, this is important. This is a line of best fit. So we're using the linear regression function on our calculator. So go to menu, go down to statistics, go to stat calculations, and go to linear regression mx plus b. It doesn't matter which one you pick. I just like mx plus b because that's what you learned in this course. So click on mathematics for x. The y value is physics. Click on OK. And I'm going to go ahead and copy this to my page over there. All right. So, I'm sorry. I'm sorry. I should have muted that as well. Okay. So, I'm going to paste this in. We got this. Now, the correlation coefficient, folks, and I don't need to, actually need to rewrite it, but the correlation coefficient is the value of r. So, the value of r is right here. 0.921544, blah, blah, blah. It says round to the nearest hundredth. That is 2 decimal places, folks. 2 decimal places to the right. So that is going to be r is equal to 0.92. That is the linear regression. No, sorry, that is the correlation coefficient of this linear regression model. And that's it. Now, there's a follow-up question. Explain what the correlation coefficient means with regard to the context of the situation. Well, the correlation coefficient is positive. So that means that there is a strong, oh, that's what I forgot to mention before. This is very close to positive 1. If you have a correlation coefficient that is very, very, very close or somewhat close to positive 1, like I'm talking like above 0.9, close to positive 1, that's a strong positive relationship. If, however, it was a negative 0.92, that would be a strong, still strong, but a negative relationship. And anything like below 0.6, it's like moderate, then it gets weaker. And then if the correlation coefficient is 0, that means that there's no correlation whatsoever. So we go over here now. There is a strong positive correlation. That's what you have to state between mathematics and physics scores. Nice. I should spell scores correctly. Cool. All right, moving on to number 32. The graph of the function f of x is equal to ax squared plus bx plus c is given below. Could the factors of f of x be x plus 2 and x minus 3? Based on the graph, explain why or why not. So the factors are x plus 2 and x minus 3. Are they? Well, let's take a look here. Over here, this is the root x is equal to 3. Well, if the root is x equals 3, Therefore, the factor is, in fact, x minus 3. We just take the opposite of what the value of the root is. Over here, this is x is equal to negative 2. Therefore, the factor is, in fact, x plus 2. So, the factors are x plus 2, x minus 3? Of course they can. Absolutely. We just proved it. So we could say yes, because the zeros shown are x is equal to negative 2 and x is equal to 3. And x is equal to 3. So, the factors are the opposite values of x. And you can put this in parentheses just for clarification if you want to. You don't have to. It doesn't really matter. Since the factors need to be set equal to 0. That's an ugly z. So, they are, in fact, x plus 2 and x minus 3. Done with that question. Not too bad. Moving on to the part 3s now. These are a little bit more in depth, but not that much challenging. 33 says, Jim is a furniture salesman. I would never in my life want to work on commission. His weekly pay is $300 plus 3.5% of his total sales for the week. Jim sells X dollars worth of furniture during the week, right? A function, P of X, which can be used to determine his pay for the week. So this is actually a linear equation. So we're going to write P of X is equal to. Now, his weekly pay is $300. That means that regardless of how much furniture he sells or does not sell, they're going to pay him $300 a week, which is really, really nothing. Like, that's no money. But he better be a good salesman. I'll tell you that right now. So this is technically like the Y-Intercept. It's the intersection when, like, time t equals... Well, actually, when x equals 0. If he sells no furniture, he's still making $300. So this is called his fixed pay. And you'll see why I put it at the end in the moment. This is his fixed pay. So, on the other hand, he gets 3.5% for X dollars that he sells. So, 3.5% expressed as a decimal is 0.035x. Ladies and gentlemen, that is, in fact, his equation to determine his pay for the week. Now, that 0.035, that's your 3.5% expressed as a decimal, and that X is the total dollars worth of furniture he sold in the week. Okay? And this, as you can see, the reason why I put it in this form, it's y equals mx plus b. It's a line. That's why I put the 300 at the end. But that is your equation. You could absolutely put the 300 before the 0.035x because addition is commutative. It doesn't really matter. Moving on to the next part of the question, use this function to determine Jim's pay to the nearest cent for a week when his sales total $8,250. So maybe he is a good salesman. So basically what you're doing is you're plugging in 8,250 in for P of X. So again, P of X is 0.035x plus 300. We are evaluating P of 8,250. Okay, let's go ahead and plug it in for X. So we get 0.035 times 8,250 plus 300. When you plug this into your calculator, 0.035 times 8,250 plus 300. He's bringing home 588.75. There we go. So P of 8,250, that's 588.75. So just write it nice and clean with a dollar sign, 588.75. Done. Moving on to the next question, 34. Omar has a piece of rope. Okay. He ties a knot in the rope and measures the length of the rope. He then repeats this process several times. Some of the data collected are listed in the table below. State to the nearest tenth the linear regression equation that approximates the length y of the rope after tying x knots. So let's go ahead and type this into our calculator. Here we go, once again. All right, so I don't need that. Go to our list and spreadsheets. This is going to be the number of knots. And this is going to be the length of rope. All right, here we go. So we have 4, 5, 6, 7, 8. Let's make sure 4, 5, 6, 7, 8. Yep. Okay. Now you have 64, 58, 49, 39, 31. So let's go to Control Dock, add a calculator. Turn off the volume. Go to Menu. Go to Statistics. Go to Stat Calculations and go to Linear Regression MX plus B. Type in for this is the number of knots and the length of the rope for the X and the Y respectively, and this is your linear regression equation or your table. So I'm going to go ahead and take a picture of this. It's your job to copy it down on your Regents exam. Okay. So I'll tell you exactly what you need to copy down for the Regents. You need to copy down what I personally would. I would personally copy down the title of what you're doing. The title, I would definitely copy down the title, the regression equation, the M, and the B. We don't really care about the correlation coefficient because it's not asking you for that and doesn't even ask you later in the problem. So I would definitely copy down the first 4. Now it says here to write down the linear regression equation to the nearest 10th. Well, it's nice. Everything that they gave you here, they were actually pretty nice. Everything that is here is in fact rounded off to the nearest 10th. So your answer is just going to be y is equal to negative 8.5. That's your slope, x, plus 99.2. Done. Move on to the next part. Explain what the Y-intercept means in the context of the problem. So what is Omar doing? He has a piece of rope, and he starts off with just a rope with no knots in it. That's when time t equals 0, or that's when he has 0 knots in it. Okay. So it doesn't. So you're plugging in 0 in for x. That's the initial amount of what he started with before he started going and tying the knots after so much time. So, what does the Y-intercept mean? Well, the Y-intercept is 99.2. That means that when there are no knots in the rope or on the rope, the length of it is 99.2 centimeters long. That's an easy part of the question. Now the second part, or the third part I should say, it says explain what the slope means in the context of the problem. Well, the slope is negative 8.5. So that means for every time he makes a knot, the length of the rope is decreasing by negative 8 point. Actually, let me rephrase that because I just said it twice. The length of the rope is decreasing by 8.5 centimeters each time he makes a knot. So, what you're going to say is this. Each knot tied on the rope will decrease the length by 8.5 centimeters. There is a negative, because it says explain, so there is a negative relationship between the number of knots and the length of the rope. Well, that makes sense because every time you tie a knot, the rope does in fact, it's not getting, like, I mean, the rope is still, the material's still there, but the length is getting smaller. That's how you answer that question. Moving on to number 35. The drama club is running a lemonade stand to raise money for its new production. A local grocery store donated cans of lemonade and bottles of water. Cans of lemonade sell for $2 each, and bottles of water sell for $1.50 each. The club needs to raise at least $500 to cover the cost for renting costumes. The students can accept a maximum of 360 cans and bottles. It says write a system of inequalities that can be used to represent the situation. So there are two variables here. I'm going to let L equal lemonade, and I'm going to let W equal water. So let's talk about the cost first. Cans of lemonade sell for $2 each. Okay, that's important. $2 each for lemonade. We have $1.50 for water. And they want to raise at least 500. So that means 500 or more. Of course, they don't want to just stop at 500. They want to raise a little bit more, right? So that first inequality is going to be 2 times the lemonade, which is $2 times the lemonade, plus $1.50 times, let me get rid of that zero, $1.50 times W for water. And that's going to be greater than or equal to 500. So remember, L and W are the amounts that they sell for lemonade or water. So either in cans or bottles. Now for water, why am I saying water? No, that's done. That's good. So now it says the students can accept a maximum of 360 cans and bottles. Well, we don't know how many is each, so we're just going to say the amount of cans of lemonade added to the amount of bottles of water cannot exceed 360 cans and bottles. So this, ladies and gentlemen, is your system of inequalities for this situation. The first inequality represents the dollars that they need to earn, which has to be greater than or equal to 500 at the end, and they cannot exceed 360 cans and bottles. So those are your two systems of inequalities. All right, moving on to the next part of the question. I assume that they wanted us to solve. So, yep. The club sells 144 cans of lemonade. What is the least number of bottles of water that must be sold to cover the cost of renting costumes? Justify your answer. So you need to be smart about this. There are two inequalities. Believe it or not, if you plug it into the one that you're not supposed to be using, you get the question wrong. It's saying here, think about it. It's saying the club sells 144 cans of lemonade. Okay. What is the least number of bottles of water that must be sold to cover the cost of renting costumes? Folks, the cost of renting costumes, that's moolah, that's money. You're using the first inequality. You have to use the first inequality. We don't care how many bottles of water must be sold, because here's the thing, that's easy. We know if there's 144 cans of lemonade, we could figure out how many bottles of water they have to be. We don't care about that. We need money. So use the first inequality. That's what you got to do. So we're going to take 2L plus 1.5W is greater than or equal to 500. We're going to solve for W, given that we have 144 cans of lemonade that we sold. So 2 times 144 plus $1.50 times W is greater than or equal to 500. Let's go ahead and solve for W. 2 times 144, that's going to be 288, plus 1.5W is greater than or equal to 500. Subtract the 288 on both sides. Once we have this, we have 1.5W is greater than or equal to 212. Now we are going to divide by 1.5 on both sides. That's ugly. We have 1.5. Divide by 1.5. Cancel those. We get W is greater than or equal to 141.3, repeating when you type this into your calculator. But when's the last time you bought a third of a water bottle? Yeah, this is certainly a third of a water bottle, right? No. It is, you need to round it up. So it says, what is the least number of bottles that they could sell? Well, the water bottles, I mean, there has to be, in order to make money, they have to sell 142 bottles of water. That, ladies and gentlemen, is how you answer that part of the question. Moving on to the next one. Okay, there was a serious problem with this question, and you'll see it a little bit later in the second part of the question. So, the first part's easy. It says a manager wanted to analyze the online shoe sales for his business. Great. He collected data for the number of pairs of shoes he sold each hour over a 14-hour time period. He created a graph to model the data as shown below. Okay. The manager believes that the set of integers would be the most appropriate domain for this model. Explain why he is incorrect. So, keep in mind that the domain are your x values, in this case time, t in hours, and he's saying that integers would be most appropriate to use. Why would that be inappropriate to use? Because they're saying explain why he is incorrect. He is incorrect, but why is that true? Well, let's take a look. Integers are essentially all the positive whole numbers, and they are all of the negative whole numbers. So the and 0, of course. But the whole numbers are 1, 2, 3, 4, 5, 6. So those are the counting numbers. The integers are 0, 1, 2, 3, 4, 5, and in the reverse direction, it's -1, -2, -3, -4. I do not remember having -1 hour. I just don't remember that in my everyday life. So the manager, of course, is incorrect. So the manager is incorrect. Because the set of integers includes negative numbers. Which is inappropriate because time can't be negative. And that's all you have to do for that part of the question. That's easy. That's not bad. Now things get a little tricky here because the state made a mistake, and I'll be more than happy to explain the two answers that they accepted. It says state the entire interval for which the number of pairs of shoes sold is increasing. There were two answers that they accept. I'll tell you what they were going for, because the people who write this exam or these exams, sometimes they have some serious misconceptions about mathematics. I'll tell you that right now. They wanted you to say from 0 to 6 because, of course, the slope is positive, right? That's what they wanted you to say. So here's the first answer that they accepted for the interval. So 0 is less than t, which is less than 6. So that's the interval. Yeah, so that's the interval. 0 is less than t, which is less than 6. And this is the hourly rate of shoes. Oh, hold on. This is the hourly rate of shoes that are sold, which increases every hour. Now, that's absolutely true. That was the first answer. That was the original answer that they accepted. But there's another answer. It says state the entire interval for which the number of pairs of shoes sold was increasing. Folks, the whole thing is increasing. And you're probably saying to yourself, what are you talking about, Trevor? It's negative past here. Why is it increasing? Well, think about it. Think about it. Look at this. This is a P of T. On the left-hand side, it says the number of pairs of shoes sold in the previous hour. Folks, in the 7th hour, they're still selling 118 pairs of shoes. Even at the 13th hour, they're still selling, 34 pairs of shoes. They don't stop selling pairs of shoes over the 14-hour interval. They don't stop. Now, if you want to talk about where is the rate of shoes being sold increasing, that would be from 0 to 6. But technically speaking, the entire interval for which the number of pairs of shoes are sold is increasing, it's actually the whole thing, the whole graph. The entire graph is where shoes sold are, in fact, increasing. They don't stop selling shoes. So that, ladies and gentlemen, is actually the other answer that the state of New York accepted. So you could say this answer too. You could say that 0 is less than t, which is less than 14. Okay? Because this is the total number of shoes sold. Does in fact increase every hour. So they just made a conceptual mistake. But of course they say that like the wording issues are bad. Nope, there's no wording issues. They just don't understand what the hell they're talking about. So those are your two answers. And I hope that you understand why both answers were accepted. And I hope that you understand why the darker blue is technically incorrect, but they still accepted it as that was the original intent of the answer. So for the next one, it says determine the average rate of change between the 6th and the 14th hour and explain what it means in the context of the problem. So basically you're finding the slope between 6 and 14. So at the 6th hour, the y value is 120. At the 14th hour, that's 14 comma 0. So calculate the slope. That's just your change in y over the change in x. Nothing new. Change in y over change in x, which is just the same thing as y2 minus y1 over x2 minus x1. That is going to be 120 minus 0 over 6 minus 14. That's going to be 120 over negative 8. So that is going to be an answer of negative 15. So that, ladies and gentlemen, is the average rate of change. What does this mean? Well, this means that... actually, let me put this in a sentence. This means that 15 fewer shoes were sold each hour on average. Keep in mind that this is an average. I'm not saying that that each time it decreased by 15 shoes. I'm not saying that. They want the average number of shoes. So that's just drawing a line from here to here. And on average, you're decreasing by 15 shoes each hour. And that's all it means in the given context. And that's how you do that problem. Moving on to the final question. Number 37. Understand by now that the last question on the Regents exam, on the Algebra 1 Regents, usually has something to do with systems of equations. Let's take a look at 37. At B's pet shop, the number of dogs D is initially 5 less than twice the number of cats C. If she decides to add 3 more of each, the ratio of cats to dogs will be 3/4. Write an equation or system of equations that can be used to find the number of cats and dogs B has in her pet shop. So, I'm going to let D equal dogs. And I'm going to let C equal cats. They tell us what the dogs are. Dogs is 5 less than twice the number of cats. So your first equation, let D equal 5 less than twice the number of cats. So that's 2 times the number of cats and 5 less of that, which is minus 5. So that's your first system. Your second system, now keep in mind here, she adds 3 more to each. Okay. And the ratio of cats to dogs will be 3/4. So cats divided by dogs is 3/4. Well, she has cats, right? She adds 3 more. Divide that by the dogs, add 3 more. And this would be in a ratio of 3/4. That's cats to dogs. Ladies and gentlemen, this is, in fact, your system of equations. It's the dogs and then the ratio of cats to dogs. And that's how you answer that first part of the question. Now, I assume that they're going to ask us for a whole bunch of solving stuff. Yeah, could B's pet shop initially have 15 cats and 20 dogs? Explain your reasoning. Well, you're going to let D equal... I'm sorry, that's not D. You're going to let C equal 15, and you're going to let D equal 20. So it says here initially. Well, let's go ahead and plug in 20 into our initial dogs equation, which is D equals 2 times C minus 5. All right, so D equals 2 times C minus 5. Go ahead and plug D into here. Why did that go away? Okay. Take the 20, plug it in. Take the 15, plug in for the cats. So we have 20 is equal to 2 times 15 minus 5. So that gives us 20 is equal to 15 times 2, which is 30, minus 5. Well, that's 20 equals 25. That, ladies and gentlemen, is not a true statement. So, could they have that many dogs and cats? The answer is no. So your answer is no. 15 cats and 20 dogs do not balance the equation D equals 2C minus 5. Okay? And that makes the most sense for your explanation. Now, could you use it on the other equation? Yes. I would not work with fractions, though, because, why not work with polynomials, right? Move on to the last part of the question. Determine algebraically the number of cats and the number of dogs B initially had in her pet shop. Initially. So that means when D is equal to 2C minus 5. So what are we doing here? Let me go back real quick and let me copy this this system of equations. Okay, I'm going to paste it over here real quick. Okay. So what we're doing is we're finding the initial amount of dogs and cats. Well, we need to solve for both C and D eventually. So what we're going to do is we're going to take 2C minus 5, and we're going to plug it in for D, and we're going to solve for the number of cats first. So we're going to solve for the cats. I'm personally not a cat person. I'm a dog person. My little dog over here is sleeping. His name's Rollo. Solve cats. So we have C plus 3 divided by 2C minus 5 plus 3. That is equal to 3/4. Let's see. This is C plus 3 divided by 2C minus 2. That equals 3/4. We are now going to cross multiply. C plus 3 times 4. 3 times 2C minus 2. So we get 4 times C plus 3 is equal to 3 times 2C minus 2. Now we're going to solve for C. Distribute the 4. Distribute the 3. We get 4C plus 12 is equal to 6C minus 6. Let's go ahead and solve for C. I'm going to subtract that 4C on both sides. We get 12 is equal to 2C minus 6. We're going to add over that 6 on both sides. We get 18 is equal to 2C. Divide by 2 on both sides. We get the number of cats is equal to the number 9. Great. So I'm going to take that 9 cats, those 9 cats, and I'm now going to solve for the number of dogs. All you're doing is you're literally taking the 9 and you're plugging it into the first equation. D is equal to 2 times 9 minus 5. The number of dogs is going to be 18 minus 5. The number of dogs is going to be 13. So your final answer, ladies and gentlemen, is dogs is equal to 13 and cats is equal, that's not cats, cats is equal to 9. And that, ladies and gentlemen, is the final answer to that question. I hope that it was helpful to you. Make sure that you hit that subscribe button down below. You could use me for many years on end for geometry and algebra 2. Make sure that you visit my website at www.nysmathregentsprep.com and consider becoming a patron on my Patreon page. All of these links can be found in the description below. And I hope to see you soon.